Good day, 11s. This video is about chapter 3b, factorizing expressions. When it comes to factorizing expressions, there are a various of methods that we use. Start with the simplest, factorize with the highest common factor. I also suggest everyone, when you get a question asked you to factorizing, it is essential that you should always check this method first. Okay, now let's take a look about this question here. Negative 3x squared plus 6xy minus 9x cubed. So when we're taking highest common factors, we firstly would investigating the numerals. So here we have negative 3, positive 6, and negative 9. So the highest common factor of these three numbers is going to be negative 3, okay? So we're going to take the negative 3 out. And then let's take a look about the highest common factor between x squared, xy, and x cubed. Clearly that the x is the highest common factor. Once we identify the highest common factor for each of the terms, we take the highest common factor out and we put the remaining factors in. Here I'm just doing it slowly by rewrite each of the term in the factor forms so you get a better understanding how we undergo this process. So negative 3x squared, I can rewrite it as negative 3 times x, okay, plus 6xy, I can write as 3, because I'm going to take the negative 3 out, so I'm going to write as negative 3 times negative 2, because we know that these two multiplied will give us a 6, yeah, times x times y. And then you have the last one plus negative 3 times positive 3, okay, times x times x times x, that's x cubed, okay? So we know that the highest common factor is going to be negative 3x. So what you can do, you can highlight the negative 3 and x, so the remaining factors will be in the bracket, okay? So when you take in the highest common factor out, first term you have an x remains, and the second one you have a negative 2y remains, and the last one you will have a positive 3x times x, which is 3x squared left. Okay, so this is how we factorize expression using the highest common factors. Okay, now let's look at the second method. The second method is factorize by group. You can find some clues of determine which method you're going to use. When it comes to factorizing groups, they often start with 4 terms. So for this example, you have the 4 terms. Okay, so in general, okay, for this method to work, you're going to group particular 2 terms together and the remaining 2 terms to form another group. So here it is very important for you to choose the right group. Here I'm going to demonstrate a bad example. Let's say if I'm going to pick the middle 2, okay, so I choose these 2 groups. I find out there are common factors in between these 2. However, if I choose these 2, then these 2 here, negative 2x squared and negative 9y, have to be sit in another group. If it's in this case, you will not be able to identify any common factors between the negative 2x squared and the negative 9y. In this case, we cannot carry on. Therefore, it is important to check the groups that we had split will always have common factors in each group. So here, I'm going to just group the first 2 and group the last 2. I'm going to firstly write a bracket to cover the first 2, and then I'm going to write a bracket to cover the last 2. All right, next step, we're going to try to take the highest common factor out of each bracket. So here I'm going to just speed up a bit. So here I'm just saying you have the factors of negative 2x, okay, that's the highest common factor for the first 2 terms in the bracket, and here you have x left, and then here you have a -3 left. Okay, now when I do the same for the second one, I have a common factor of 3y, okay, and then I take that out, I got x minus 3 left. All right, you should end up with common brackets for each of the term here, okay? So you have a common brackets, which is x minus 3. Now you're going to treat the x minus 3 all together, including the brackets, as our common factor. So you take that out. The remaining factors in first term is going to be -2x. The remaining factors in the second term is going to be 3y, okay? This is how we factorize by group. Next, let's look at factorizing using formulas. So basically, there are two major formulas we're using here. The first one is difference of squares. Okay, so the difference of squares, or sometimes we call them DOPs. You have to make sure that you are familiar with this formula, okay? A squared minus b squared equals to bracket a plus b times a minus b. In order to carry out this method, there are two critical things we need to look at our question here. Firstly, it should with only two terms, right? Only has two terms for this one to work. And secondly, between each square terms, there must be a minus. So we can say you are finding difference, okay? Otherwise, you cannot use DOPS method. This is not in the complete square form, okay? So 25x squared, we need to write the square form, meaning both the coefficient and the pronumeral should be right together with something squared, okay? So here 25 is 5 squared, x squared. So we should rewrite this as 5x everything squared, okay? Similarly with 16y squared, we can write as 4y everything squared, okay? So that equals to 5x squared minus 4y squared. So you now have identified this is your A and this is your B. Okay, so here you have the A and the B. So now being identified the two base here, you can just put in the bracket. Okay, you put in the bracket. So you get A, which is 5x, plus B, which is plus 4y. And then you get A minus B, which is minus 4y. Okay, so there is no other common factors in each of the brackets. Okay, so that's the simplest form. Here come to the second one, perfect squares. With perfect square formulas, again, you have to be familiar with this formula here, okay? So you get a term squared, and then in the middle, it's going to be adding double of the product of the two base. For a question like this, the first thing we always do is to check in whether we have a highest common factor to take out. So for this question, there's a highest common factor. We can take the -2 out. Okay, and then you have x squared minus 8x plus 16. Let's rewrite each terms so that we're trying to match with the formula here to help you to identify A and B. So here x squared, we just write x squared. Minus 8x, I can write it as a plus 2 lots of what? If you want to convert into plus 2x times something, this number must be -4 because you should end up with a negative term, yeah? So it's -4. Pretending that the b is -4, then b squared, which is -4 squared, and then we do have a -4 squared, which is positive 16, okay? So in this case, we match with our perfect square formula. Then we can identify this is your A, right? The x is your A, and -4 is your B, okay? So in this case, we can just put them in the bracket. We have a -2, and A is x, and B is -4, and squared. Okay, next we're talking about the main concept for factorizing a quadratic trinomials. Now notice here trinomial means 3 terms, a quadratic, and we know what quadratic is, yeah? Start with the monic ones. Monic means the leading coefficient equals 1. That is the simpler case. So with this formula here, we're going to consider the constant here as the product of two integers. Notice here the integer means it can be positive or negative, okay? And then these two particular factor of the constant can be also add up, that is going to be equivalent to the coefficient of the x term. If you find this pair of integers, and then these two integers will give you the factorized form, which is x plus one integer in one bracket times x plus another integer, okay? So the key here is to identify the factors of the constant. Okay, you have to identify the factors of the constant first, and then you can choose which pair of the factor will add up to give you the coefficient of the x term. So here I'm going to using this as example. Let's quickly check, can we find any highest common factors? Well, there's no highest common factor at all, or we can say the highest common factor is only one, right? Now we have the 6, okay, so this is a constant 6. We're going to firstly write out the factors of 6. So you can have 1, 6, well 6 times 1 in this case are exactly the same, right? And then we have the 2, 3. Don't forget we can also have a negative 1, negative 6, negative 2, negative 3. Then we're going to add each pairs of the factors to see whether they will give me the total that is equal to the coefficient of the x term, which is here negative 5. And then we can see that only the last one give us negative 5, okay? Tells you this negative 2 is going to be m, this negative 3 is going to be n. Doesn't really matter which one you choose for m or n, because as they are multiplying, switch won't make any difference, okay? You can say this expression can be factorized as x minus 2, x minus 3. Now, let's check the second example here. We do exactly the same, however, here our constant is negative 6. Okay, so when you find the factors of negative 6, you must have one factor being positive, one factor being negative. Okay, so if I'm choosing negative 1, positive 6, and then I can also choose positive 1, negative 6. Okay, notice here this becomes a pair. And then you can have 2, negative 3, or negative 2, positive 3. Okay, so here I'm just going very quickly. So these two add up into positive 5. Okay, however, what I want here, we want negative, so we want a negative 1. So this one doesn't work. And you add this up, you get negative 5, doesn't work. For this one, you get exactly negative 1. So the last one is positive 1, so it doesn't work. Okay, so we're going to choose the middle one here. And then you can say 2 is equal to m, and then n is equal to negative 3. So this we can factorize as x plus 2 and x minus 3. All right, now let's move on to the last concept here, which is how to factorize a non-monic quadratic trinomials. So when it comes to a non-monic, the first thing you always check is whether you can find any highest common factors or not. Okay, so here we can find the highest common factor, which is 2. So we take 2 out. And okay, now we take the highest common factor out with 2 out, and then we have here minus x, and then here we have minus 3. Okay, for the non-monic, I'm going to show you with two methods. With method 1, okay, you have a few extra steps on top of the existing factorizing monic situation here. So step 1, you're going to multiply leading coefficient and the constant. So you multiply leading coefficient and constant. So in this case, I'm multiplying the 2, which is leading coefficient, times negative 3. So that will give me negative 6. The second step is to find out factors of the product, which in this case we get the 4 and negative 6, that the sum of the two factors is equal to the coefficient of the x. Okay, so again I'm going to do find out the factors. Okay, 1, negative 6, negative 1, 6, 2, negative 3, negative 2, positive 3. So when we add them up, I want to match with the coefficient of the x. In this case is -1. So these are not right. It's only this one. Okay, so 2x and -3x. Step 3 is you rewrite the x term as the two factors add up. Okay, so what do I mean by this? So you got to rewrite -x. You can rewrite it as -x as 2x plus -3x. Okay, or you can say 2x minus 3x. I'll just keep as -3x here. Okay, plus -3x. So after we do that, we're going to rewrite the whole expression again. So we can say that is equal to 2 and then 2x squared plus 2x, okay, and then minus 3x minus 3. So now you have 4 terms, which sort of give you hints that we're going to use in a factorized by group, okay? So we're going to group these two and we're going to group these two, okay? So I'm going to do it here, continue here. So that will equals to, so put this in this square bracket. The first bracket here, we're going to take the common factor straight away. So we have 2x with the common factor, and then you have x plus 1. The second one, you're going to take the -3 out, and then you have x plus 1. Okay, we can say there's x plus 1 also is being a common factor, so you take the x plus 1 out, and the remaining term, which is 2x minus 3. That's the other factor. Okay, so this is how we're going to factorize anomalic quadratic trinomials using factorized by group. Okay, now this is the first method. I'm going to also show you how the second method works. The second method is also introduced in the textbook as well. If you want to take a look about this method in detail, go check the textbook examples. So in this case, we're going to write differently. So we're going to rewrite the 2x squared, okay, as 2x times x. So the rule here is the factor that you rewrite the leading term must have an x for each factor. Okay, you cannot have a 2x squared and the 1. You have to have at least the one factor contains an x. So here we have 2x and x. And then you're going to rewrite the -3 as its factors. So for example, if I'm trying with -1 positive 3, for example, okay, like this, you're going to multiply diagonally. So now you get -1 times x is -x, yeah, plus 2x times 3, which is 6x. So this will equals to 5x. This is not the right combination since we're trying to match the coefficient in the x term, which is -1 here. So this combination doesn't work. We're going to try something else. We swap the numbers here, like so. Undergo this cross multiplication. So you end up with 3x minus 2x. You get 1x, which is the opposite sign. How can we change this? Well, it is easy. We just swap the signs, right? So keep these 2x and x. So this is not working either. I just need to put the negative sign in front of 3 instead of 1. We get 2x minus 3x that equals to -x, which you got a match with the middle term. How are we going to write our result? It's important to notice here, the first bracket is going to be the top row. So that is the first bracket. And the second row here, second bracket. So these are all the methods that we normally using in factorizing expressions. Have a go with the exercises, guys, over the weekend. Go through my notes. If you have questions, make sure you ask me or come to Messenger Message support. I see you guys in the next video.